Hey Algebra 2, here are your notes on Lesson 7.7, Solving Equations and Inequalities Containing Radicals. So the properties of radicals can be used to solve equations. Equations that contain variables in the radicand of a radical are called radical equations. So we've seen some of these before, we've just never been able to solve them. So first up, when we are attempting to solve equations with radicals, what is our goal? I like to remind myself of the phrase isolate and eliminate. This essentially tells me that my first goal of the problem is going to be to isolate the radical. If I isolate the radical, I can deal with it. If it's not isolated, there's more steps to simplify before I isolate. Once I've isolated it, I'm going to use a few different methods to eliminate. The first one being usually just squaring it. The majority of these are going to be square roots, so it makes sense that we are going to square them in order to get rid of the radicals. That's the first goal. The second goal is to make sure I am checking my solutions. Check solutions. Can't write and speak. By checking my solutions, I know right off the bat that radicals come with a lot of baggage. There's things to be aware of with negatives. There's things to be aware of with taking the square root and squaring things. So by checking my solutions, I'm just ensuring that I didn't make a mistake somewhere along the line or possibly break one of those unwritten rules. So let's just jump in, see what these look like. So first problem, square root of 4w plus 6 equals 2. My first step is to isolate and eliminate. This is already isolated. Notice there's no other numbers around it. If there was, I would try to get those away so that I could take the next step, which is eliminate. If you're taking the square root of something, it makes sense that to eliminate the square root, you would square it. But whatever you do to one side, you must do to the other as well. Not too tricky. When we take the square root and we square it, we're left with 4w plus 6 equals 2 squared, which is 4. That's all that is. That's all solving and simplifying these takes. From here, it's going to be usually linear simplification. So we're going to minus 6 over. We're going to get 4w equals negative 2. And then w equals negative 1/2. But I also want to check that solution. Remember, go back. That's my second goal. Make sure I didn't make any mistakes along the way. So I'm just going to go ahead and take this number and plug it directly back in. Negative 1/2 times 4 is negative 2 plus 6. That is the square root of positive 4, which should equal 2. That's a true statement. I checked it. That answer is good to go. That's all it is. So let's see another one like this. Notice, isolate and eliminate. This square root, this radical, is not isolated. So the first thing that I'm going to do is work backwards from PEMDAS, and I'm going to subtract the 7 to the other side. Once I do that, now I have the square root of a minus 3 equals negative 6. And here's where I would square both sides. However, I'm going to write in big bold letters, stop. Why am I writing stop here? Why is this suddenly a problem? Well, if we look at this, this equation says that the square root of something is equal to negative 6. However, from our previous knowledge, we know that square roots can't be negative because they create imaginary answers. So right here, if we see a square root equals a negative, we should immediately get a big red flag and recognize that square roots cannot be negative, cannot equal or be negative. Knowing that, and knowing that we can't go any further without breaking something or having an imaginary answer, we can stop right here and say that there's no real solutions. There's nothing right away that we would be able to do to this in order to not get an imaginary number. So, you've got two options when solving these. You've either got an answer that you can check, or you're going to get something equals a negative and be able to stop. I suggest you practice a lot of these problems because they're going to pop up and a lot of you are going to want to solve these. Unfortunately, you can't do that. We have to recognize that this is as far as we can go. All right, solving some harder equations. Well, they look harder. They're not really. Same thing. We're going to isolate. I'm going to move that 3 away first. Opposite of PEMDAS says I'm going to do all my addition, subtraction. So I'm moving that over. 2x times root 3 equals 2. Now that I've done my addition, subtraction, continue moving backwards to the multiplication, division. Divide both sides by 2. I now have x times the root of 3 equals 1. And now the only way to get rid of this radical is to square both sides. This now gives me x squared times square root of 3 times square root of 3, which is just 3. And then on the right side, I have 1. From here, it's technically a quadratic solve, so we're going to do x squared equals 1 over 3. I take the square root of both sides and simplify, so x is positive and negative root 3 over 3. I've now isolated and eliminated. I have my answer, and now I have to plug it back in. So 3 plus the positive version, I'm going to start off positive, 2 times 3 root 3 times 3 equals 5. All right, simplification again, move that over, we get 2. This becomes 3 over 3, which is 1. When I move that over, I get 2 times 1 on the left side, and I get 2 equals 2. So the positive answer works. What about when I throw the negative answer in there, however? 3 plus 2 times negative root 3 over 3. In this case, I'm actually going to get a negative 2 on my left side and a positive 2 on my right side, which does not work. So the only answer I can actually circle here is going to be the positive answer. I cannot have the negative version. So even though we technically have 2 solutions, one of them is going to be extraneous. One extraneous. It's a really big math word. One extraneous solution. And we do not include those extraneous solutions. So we just cross that out. Or you can rewrite it. All right, let's keep going. When we have a square root equals a square root, we're going to handle it the same way. If I want to get rid of something, I can do it to both sides. I now have 12 minus x equals x plus 6. Here I'm going to simplify. I'm going to move this x over. 2x equals 6. X equals 3. Let's plug it back in. Check our answer. 12 minus 3 is 9, so that would be the square root of 9, which is 3. Equals 3 plus 6, which is the square root of 9, which equals 3. So both of those work. Our answer is good. One more here. Let's work backwards to isolate first. Move the 1 over and then divide both sides by 2. I'm doing 2 steps in one here. Try to stay with me. Minus 1 is 14. Divided by that 2 is 7. Remember, opposite of PEMDAS when we're solving. Here we're going to square. We get 3x plus 4 equals 49. And solve. Minus the 4 over, you get 45. 45 divided by 3 is 15. So x equals 15. Let's throw that back into our original. 15 times 3 is 45, so I'm just going to simplify that right away. And let's check. 45 plus 4 is 49. Square root of 49 is 7. 7 times 2 is 14. 14 plus 1 is 15. Good to go. Our answer makes sense. So there are a couple of examples. Now, that being said, let's flip over to the back. for a few more challenging ones. And I know I haven't gone through any more challenging ones. However, I would like you to pause the video at this point and see what you think you have to do in order to solve these. It's okay if you don't get them, I just want you to attempt them. And then come on back, we'll do them together. Alright, hopefully you had a minute to try those on your own. If you weren't super confident yet, totally okay too. We're going to go through them together. So, this first one, I can't square this entire side because I'm just going to have too many radicals going on. Too much, don't want to deal with it. So what I'm going to start by doing is actually moving one of the radicals to the other side. X minus 8 stays here, and I get 1 minus the radical x plus 3 on the right. Now, by doing this, I can square both sides, and I just create a small foiling problem for myself on the right. That I'm not too overwhelmed by. X minus 8 on the left, and then I'm going to FOIL this out. Remember, this is not something where we distribute that 2 into both terms. We actually have to write this out as a binomial times a binomial. I'm going to skip writing that out and just go to the solving bit. 1 times 1, when I do that, is going to be 1. It'll be 1 times this, same thing, so I'll have negative 2 roots of x plus 3. And then a negative of that times a negative of itself is going to be a positive x plus 3. If you need to see that worked out, don't hesitate to let me know. I'd love to do that for you in a different video. From here, it's just simplification of this right side and then kind of combining like terms across the equal sign. So in this case, I'm going to move this x over, x minus x, no x is left, and then I've got a negative 8, which I'm going to move the 1 over and the 3 over. So when I do that, I'm left with negative 2 times the root of x plus 3. And then on the left side, because I moved everything and combined like terms, I'm left with a negative 12. Again, that's just 1 plus 3 minus 4 from both sides. You get negative 12. I also canceled that x by moving it to the other side, and we're left with this. From here, we've kind of created a more simple problem that requires the same methods we were using before of isolate and eliminate. This isn't quite isolated yet. I want to divide both sides by negative 2, and then I'm actually going to move the radical to the left side. That's just how I prefer to work with things. Now I've got it isolated, let's eliminate. We're going to square both sides again, just like we did up above, because what that's going to allow us to do is get x plus 3 equals 36, and x equals 33. So that problem looked really challenging, but other than this first part, we still have to use the same methods, which I think is kind of cool. However, this doesn't excuse us from having to check our answers. So let's go ahead and put 33 back into the original problem and see what we get. 33 minus 8 plus the square root of 33 plus 3, and we hope it equals 1. However, when we do this, we're going to get the square root of 25, which is 5, the square root of 36, which is 6, and we all know very well that 5 plus 6 does not equal 1. So because our solution did not end up working, this is a no solution problem. And these are very common, so don't freak out when you don't get a solution. All right, the next one has a fractional exponent. Nothing to worry about though, we're super confident with working with those since we watched those last couple videos. But we still have to isolate because technically if we rewrite this fractional exponent as a root, it's the same thing as the cubed root of 6u minus 5 plus 2 equals negative 3. Now that it's in a root, let's isolate. Cubed root 6u minus 5 equals negative 5. And right here you might be like, oh yeah, that's what she was just talking about. We have to stop here because we've got a radical equals a negative and that doesn't work. Pause. You're right, except this is a cubed root. And we talked about in some of our last videos and in class how the cubed root is allowed to be negative because negatives divide a little bit differently. If this was a square root, you would be correct. We could not have it equal to a negative, but in this case, it is allowed. So we're going to continue the same way that we would as if this was a legal problem in a square root. In this case, how do we undo a cubed root? We have to cube it. We don't square something that needs a cube, we uncube it. But whatever you do to one side, you have to do to the other. So here we get 6u minus 5 because those, boom, cancel out. And on the right side, we've got negative 5 to the third, which is negative 125. And from here, simplification. 6u equals negative 120. U equals negative 20. Let's check our answer, make sure we're not doing any funny business here. I'm actually going to throw it into this one because we're more confident with those radicals. Negative 20 times 6 is negative 120. Minus 5, that's negative 125. I should have said plus 2, but I'm just going to do negative 5 right here because that is just this step simplified down to this step. And because the cubed root of negative 125 is in fact negative 5, this works, and our answer is legit for both of these problems. Sometimes I like to do this as well because if I've already circled my answer, I like to put a little no solution next to it in case you already did it in pen, because you know how much I love when we do math in pen, even though I do it in these videos so you can see it. All right, how do we do this with inequalities? Guess what? Method doesn't change, we just have to add something. So I'm actually going to start off a little lower on the page because I personally am a list person. I like to make a list of how I'm going to do things. So when we are solving radical inequalities, we are going to find our critical values. And the way that we're going to do this is first by solving the full equation the same way we would as if it was an equality and not an inequality. The second thing we're going to do is solve for the radicand. And I'll show you why in just a minute. Solve for radicand. Remember, that's everything inside the radical. And then 3, we're going to create a number line our critical values. And yes, I'm using number line as a verb in this case. We're going to number line our critical values. So let's see what this means. Here is my problem. The square root of 2x plus 5 is greater than 3. Sorry if there's a little extra noise in the background there. So, according to the steps I just gave you, let's solve the full equation as if it was normal. We're going to take it here, I'll put it over here. We're going to square both sides right away. This gives us 2x plus 5 greater than 9. Move the 5 over, we get 2x greater than 4, x greater than 2. There's our first step. Solve it as if it's a normal equation. However, the second step is we need to check our boundary and our critical values. We know that a square root must be positive. That's just a given fact. So when I say solve for the radicand, what I'm essentially doing is I'm saying everything in the radicand I know has to be greater than or equal to 0 in order for this square root to even make sense. So what I'm going to do to solve this is I'm going to take 2x plus 5 and say it has to be greater than or equal to 0. If it's not, if there's a boundary value I need to be aware of, this is the step that's going to show me where it exists at. Move the 5 over, divide both sides by 2. I'm left with negative 5 halves. In my third step, this is going to show me where my solutions actually are. I found all the important parts, now I have to put that information together. So I'm going to create a number line, just like I'm used to with my inequalities. I'm going to put my two critical values on there. I've got negative 5 halves, and I've got 2. Now, according to this problem, x is both greater than negative 5 halves, and it's greater than 2. I'm going to ignore those signs, and I'm just going to find out what works. First off, let's test something to the left of this critical value. Something to the left of 2.5. Try negative 10. All right, if I throw a negative 10 in here, I'm going to have negative 20 plus 5, which is the square root of 15. Is the square root of 15 greater than 3? No. We know that the square... Well, what? Let me think again. What value did I use that turned out nicely last time? I had a much nicer value. I don't like to put things in here that we can't estimate, so I was trying to think of something that made more sense. But I don't remember what it was. I guess we'll stick with the square root of 15. The square root of 15 is close to the square root of 16, but not close enough, especially when we're talking about the square root of 3. So what I'm going to do is I'm going to go over here to my handy dandy Google calculator, and I'm going to type in what is the square root of 15. It's 3.87. Apologies for my mix-up here. I seem to be having a calculation error. I want to pick a nicer number than what I did, because it doesn't look as nice. Let's just pick negative 3 because it's closer. Why did that not make more sense? Haha. If I pick negative 3, which is still to the left here, I get negative 3 times 2, which is negative 6, plus 5, which is negative 1. The square root of negative 1 is imaginary, so that doesn't even work. This breaks my equation. I knew I chose a nicer number last time. I know that this is right because my original answer for my critical value said it had to be greater than negative 5 halves anyway, so this was just a nice little check. Second, let's check this middle value. Easiest value here would be 0. 0 plus 5, square root of 5 is not greater than 3, so this section doesn't work either. But when I check something over 2, say 20, I'm going to get 40 plus 5. Square root of 45 is definitely greater than 3. So my final answer would be for this problem that x is greater than 2. I could also just leave the number line as my final solution. It does a pretty good job of highlighting everything that I found. Apologies for those little mix-ups in the middle. Thanks for bearing with me. Even I make those mistakes sometimes, so don't feel bad when you make them too. All right, this next problem and our last one, if you can hang in there with me. Isolate and eliminate, same as we were doing before. 4x minus 5 less than or equal to 7. Square both sides, I get 4x minus 5 less than or equal to 49. Move the 5 over, I'm going to get 4x less than or equal to 54. Sadly, my x is going to be less than or equal to a fraction, which I know we don't like, but we can handle. I'm going to put it as a decimal because I know some of you prefer that. There's our first critical value. We got that from solving the full equation. Our second critical value is found when we take whatever is inside the radical and say it's got to be greater than or equal to 0, otherwise that square root breaks. This tells me that x is greater than or equal to 5/4. Taking those pieces of information, throwing it on a number line here, I get 13.5 and 1.25. And then check some values. Less than 1.25 is 0. I get square root of negative 5. You can't have the square root of a negative, so we already know that section doesn't work. Something over 13.5, I always throw in a big number, 100. 400 minus 5, that's 95. Square root of 95 is definitely not smaller than 7, so that section doesn't work. throw a number in the middle here. What number did I use last time? I don't remember. I know that it works, but I don't remember what number I checked. Let's throw 6 in there. Close enough, right? 6 times 4 is 24. 24 minus 5 is 19. Square root of 19 is definitely smaller than 7, so that section works. In this case, my x is both greater than or equal to 1.25 and less than or equal to 13.5. And you can check the specific values as well. In this case, I'm going to trust them here because I've seen this problem before. All right. That was a whirlwind. I know there were a few oops in there. I'm super glad you stuck with me through all of it. If you have any questions on this video or any of the other ones, please don't hesitate to let me know how I can help you.